Hi, I'm Kim from Captis Aire, my spin-out company. I'm excited to share with you today a capital and energy-efficient alternative emissions control technology for controlling emissions from wood drying. We've been working on this technology with our good partner, Environmental CNC, and a commercial-oriented strand board manufacturer since 2015. And in that time, we've learned a lot, and I'm happy to have this chance to share with you today. Now, I want to point out that while we are doing this work with an WESP manufacturer, these learnings will translate well into the wood pellet industry because the emissions are similar. So our technology controls emissions by adsorbing them using bead-activated carbon in a fluidized bed concentrator, the FBC. So the problem with emissions control devices today is they rely on oxidation to burn up the emissions. This uses a tremendous amount of energy, creates greenhouse gas emissions, and is very expensive to operate. The alternative is to very efficiently adsorb and recover those same emissions using technology that's already commercial today in many applications, including automotive and electronics manufacturing. So what we want people to know is that our work indicates that this technology can help users to meet their air emissions control requirements, significantly reduce greenhouse gas emissions, drive down operational costs, and generate revenue by transforming what would have been pollutants into valuable byproducts. So it's good for industry, and it's good for our air. So the great thing about the FBC technology is that it's already commercial in many applications today, including automotive and electronics manufacturing. Here you can see they've already demonstrated good operational reliability and safety. For example, there are no large, heavy moving parts that have to be replaced or repaired. In fact, the only moving parts are the fans that move the air through the system. This technology is only new to wood drying, and for that application, Georgia-Pacific Chemicals has already filed 2 patent applications. So the FBC has already been recognized for excellence in environmental performance. Here you can see that Honda Motors of Alabama was recognized as Air Conservationist of the Year when they implemented the FBC, when they increased production. Now, before I describe for you how the technology works, I'd like to share with you how we estimated the value of this technology. And the value of this technology is primarily in the reduction of energy required to run the system. You can see the calculations here. I'd like to point out that these are industry-accepted calculations, and there's plenty of good references to which I can refer you to learn more about how these are done. My personal favorite is from the Institute of Clean Air Companies. There are also several very good calculators by which you can input your data, and they will calculate the estimated amount of energy required to run the RTO. There's one from the EPA, from Cyclotherm, and another from Captis Aire. But all these sources use the same basic calculation, and they use one central factor. That's the specific heat of air. The specific heat of air is the number of BTUs required to heat 1 pound of air by 1 degree Fahrenheit. And that's how we did our calculations. I won't go through these in great detail, but we used the specific heat of air along with the amount of air going through the system, the density of the air, and the temperature increase in the device. We also considered the energy efficiency of the RTO, which is actually a very efficient device. However, there are heat losses. Some of the heat goes out the stack. Some of the heat is lost by radiant heat losses through the surface of the RTO. And this is the heat that we have to pay to replace. We also considered and subtracted from the amount of energy provided by the very emissions that are being oxidized. So in this example, we're oxidizing terpenes, which have a lot of energy. So we subtracted this terpenes energy from the amount of natural gas required to run the system. We crunched all these numbers and found that this system would use about 227,000 MMBTUs per year of natural gas. We can then calculate the annual cost per year. We could use today's value of about 2 or 250 per MMBTU. But if you're at the point where you're considering buying a device that's going to last you 20 years or more, you might want to think about what's your long-term outlook on the price of natural gas. Hopefully your financial guy can tell you his perspective. In this particular example, we estimated the long-term cost of natural gas at about $3.50 per MMBTU. This equates to about $800,000 a year in natural gas, and this is what we can avoid by using the FBC. Now we've calculated the amount of natural gas we're avoiding, we can also calculate from that the amount of greenhouse gas emissions that we're avoiding. In this case, about 12,000 metric tons per year of greenhouse gas emissions. And if we can sell these carbon offsets for $5 a ton, that equates to $60,000 a year for carbon offsets. I'll talk more about carbon offsets in my next slide. Another way that we can reduce energy is by reducing the amount of electricity required to run the system. And that's primarily because we use less fan power to move the air through the system. So reducing the overall horsepower of the system by 1,000 horsepower equates to approximately $400,000 a year in electrical savings. Finally, if you're recovering terpenes, you can sell these. The value, of course, depends on your yield and the price per gallon. But we know that there's about 1 gallon of terpenes in every oven dry ton of wood. So for a pellet mill that's producing 300,000 tons per year of pellets, that has this 1 gallon of terpenes per oven dry ton of pellets, and if we get a 75% yield, that equates to about 225,000 gallons per year of terpenes. At $3 a gallon, this equates to $675,000 a year for selling terpenes. Now beyond this, there could be some additional savings in avoiding repairs to those large, heavy moving parts. But this should give you a much better idea of how we've estimated the value of switching to the FBC. We've also been speaking with ClimateCo, an American carbon registry, about the value of the greenhouse gas emissions reduction. And what we're learning is that it may be possible to register and verify a project for a site that's switching to the FBC and thus reducing greenhouse gas emissions or carbon offsets. Each carbon offset is equal to 1 ton of CO2. And these offsets can be sold on exchanges. Now, there's a wide variety in pricing, and you can estimate the value of the offsets based on carbon allowances, which you can see on the International Carbon Action Partnership website. But in speaking with American Carbon Registry, they estimated the value of our offsets at about $5 per ton, which in this example equates to about $60,000 per year for selling carbon offsets. So now I'd like to play for you a short video that shows how this technology works. Now let's look inside. Process air containing emissions enters the adsorber. It passes up through a series of trays filled with activated carbon beads. Just like the carbon or charcoal you probably use in your house to clean your drinking water, activated carbon cleans the air. When the emissions hit the carbon, it very efficiently adsorbs those emissions. Then the clean air exits out the top of the adsorber. The carbon falls to the bottom of the adsorber and is transported using air from the fan to pneumatically convey it to the desorber. In the desorber, the beads are heated to release the emissions. At the same time, nitrogen gas is moved across the carbon to sweep the emissions in vapor form to the condenser. The carbon moves to the bottom of the desorber and is conveyed pneumatically back to the adsorber, where it is reused again to adsorb the emissions. In the condenser, the vapors hit the very cold surfaces of the tube and shell style condenser to convert the vapors to liquid. The liquid is then collected and sold. Finally, a small amount of carbon is continuously fed to the side stream reactivator, where it is heated to over 1400 degrees Fahrenheit to remove any residual traces of organics that might accumulate on the carbon. This ensures the carbon remains clean enough to continue to adsorb the emissions effectively. Here you can see what the beads look like when they are fluidized in the trays. When the air blows through the holes in the trays that are full of beads, it fluidizes them, which makes them look a little like they are boiling. So what you just saw was recovery, but there are instances where the value of those recovered materials are low. In those instances, we can offer concentration and oxidation as an alternative. This system still benefits from the reduction in energy usage because we can more efficiently oxidize this concentrated gas stream. So we ran pilot trials in both 2017 and 2018. In 2018, we were online for over 1,700 hours over a period of 6 months. At the end of this time, we demonstrated the ability to control the emissions. We did air emission stack tests with both John Zink and Aire, that's Advanced Industrial Resources. We demonstrated this twice in 2 separate testing events. Here you can see we demonstrated this 3 times in a row during each of the 3 one-hour tests. We also did a complete battery of stack tests. Here you can see again that we reduced the VOCs by over 90%. We also reduced the HAPs, that's formaldehyde and methanol, between 75 and 85%. And we reduced particulate from between 50 and 65%. We reviewed these results with 2 state agencies and 2 experts from the EPA. In every discussion, agency personnel were supportive of permitting for a full commercial system. It's also important to understand that while this specific emissions profile is probably different than what any of you have in your permits today, agency personnel have told us that considering the reduction in greenhouse gas emissions and the generation of a useful byproduct, they would happily accept these trade-offs. So in addition to controlling the emissions, we also collected terpenes. Terpenes are in the sap of pine trees. So when we recovered these emissions, we recovered these terpenes. These terpenes are responsibly recovered bio-based materials, and they can be sold as fuels, fragrances, solvents, etc. So this map shows the many locations where this technology can be utilized. For instance, wood pellet, oriented strand board, and plywood manufacturing. But beyond that, there are plenty of other potential sites. So this one slide really demonstrates the transformational capabilities of the FBC as compared to the RTO. In this particular case, the RTO used as much as 10 times as much energy and created as much as 4 times the amount of greenhouse gas emissions. And this is driven primarily by 2 things. First of all, the reduction in operating temperature of the FBC and the significant media configuration advantage. Here you can see the RTO was operating at over 1,400 degrees Fahrenheit to burn up the emissions. By contrast, the FBC was adsorbing those emissions at the temperature that the air came out of the process, which in this case was about 175 degrees Fahrenheit. We did have to heat the media to about 400 degrees Fahrenheit to release those emissions and enable us to reuse it. But still, you can see we reduced the operating temperature by over 1,000 degrees Fahrenheit, which drives the energy savings. We also have a significant media configuration advantage. In the RTO, they use these brittle ceramic saddles. They have 2 beds, each about 8 feet deep. So they have to force the air through 16 feet of this static media. By contrast, in the FBC, we have 6 trays of fluidized media. Each tray is about 2 inches deep for a total of about 12 inches of fluidized media. So you can see it would be much easier for the fans to move the air through this fluidized media as compared to this stacked media. In fact, the differential pressure across our system was just 3.5 inches. That's in contrast to the RTO at about 10 to 20 inches. Differential pressure and back pressure are similar. So again, you can see that we could use a 600 horsepower fan instead of a 2400 horsepower fan, which drives the electrical savings. Our system is also smaller and lighter. This means less steel and less weight, as well as a smaller footprint. This gives us the ability to locate the device in more places, including the possibility of locating it on the roof. We can also reuse our media. In the RTO, they have these brittle ceramic saddles. And when they have to do cleaning and maintenance, the operators literally have to go inside the device, vacuum out the media. When they vacuum out the media, it breaks. This means they have to buy new and replace it. By contrast, our media is bead-shaped. It looks like a poppy seed, and it flows very much like water. And when we have to do cleaning and maintenance, we can literally drain this media out of the system, do whatever cleaning and maintenance is required. In fact, we have internally mounted spray nozzles that can be controlled by the operator external to the unit. After washing the unit, we can dry it out with the fans, then replace the media. Finally, our device is inherently safer, again because of this reduction in operating temperature, the elimination of these large, heavy moving parts, and the fact that the operators can clean the device external to the unit. So now let's take a moment to hear what it's really like to run one of these devices from an experienced user that's run both the RTO and the FBC for many years. So I hope that gives you a much better understanding of what it's really like to run these devices year after year. So our pilot trials were very successful. We achieved over 90% reduction efficiency. We collected terpenes, and we demonstrated good operational reliability and safety. Our final step to commercialization is to scale up to a full-size commercial system. We're talking with a number of wood products manufacturers today and look forward to taking this final step. Last but not least, we have a great team. Hal and his team at Environmental CNC have already commercialized this technology at over 60 sites worldwide. They've overseen fabrication, installation, commissioning, and operation. This team has the necessary capabilities, integrity, and passion to deliver. If you have any questions at all, please reach out to me. We're very excited and happy to share. Thank you so much for your time. Thank you.